India is the seventh largest country by area, the second most populous country with over 1.2 billion people, and the most populous democracy in the world. Home to the ancient Indus Valley civilization and a region of historic trade routes and vast empires, the Indian subcontinent was identified with its commercial and cultural wealth for much of its long history. The written history of agriculture in India dates back to the Rig Veda, written about 100,000 BC. Today, India ranks second worldwide in farm output. Considering the tons of crop loss every year due to improper farming practices being a major reason and the ever-increasing mouths to feed, what can be done to improve this sector, which is, after all, the backbone of our country? Here comes the concept of hydroculture. Hydroculture is the art of growing commercial crops and food crops without the use of soil. These plants are grown in aggregate and a nutrient solution that is circulated in the water to provide the necessary minerals for the plant. This is the inspiration for our project. We have developed a model containing a hydro plant placed in an environment similar to that of a greenhouse.
SIM 300 GSM module, Texas Instruments MSP 430 G2553, 16x2 LCD module, 6-volt DC motor, HDC 1000 humidity cum temperature sensor, 12 volts exhaust fan, DC power supply unit, control and protection circuit, water pump.
Hi, let's go ahead and take a look at our experimental setup. Firstly, we have the Texas Instrument MSP430 launchpad with the onboard G2553 chip. This is our 16x2 LCD module. This here is the GSM SIM 300 module. Inside this package, we have installed a protection circuit for the MSP430 launchpad. This is our hydro farm which contains the money plant. Inside the setup, we have installed a DC motor and fan. This is the Texas Instrument humidity and temperature sensor. This is the ventilation fan. And finally, this here is our water pump.
Hi, let's go ahead for our project demo. Our project is aimed at being automated and requires little manual work. Since hydroculture practices reduce the intervals of irrigation, we have used the water pump to function for a very few seconds of time, that is matter of few seconds. Here we see the water pump functioning. Use of the DC motor, water pump and the exhaust fan with a microcontroller, it is required to use a protection circuit consisting of an NPN transistor, current limiter resistor and a diode as shown in the schematic. The DC motor, water pump and the exhaust fan are actuated when a control signal from the controller occurs at the base of the transistor. The diode prevents reverse current which could damage the controller if not used. Texas Instrument SDC 1000 evaluation board consists of an onboard temperature and humidity sensor of high precision. We have decided to use the sensor along with the MSP430 G2553 using the 2-wire I2C protocol. It sends the temperature and humidity in terms of 16-bit values, which is converted and displayed on the LCD. We see the temperature value. Maintaining the temperature under 25 degrees Celsius, we want the cooling fan to function for a few seconds. We want the ventilation fan to function when the humidity value exceeds 30%. Here we see the humidity is greater than 30%, so the ventilation fan functions. Required, the conditions of the setup could be sent to distant people by means of GSM messages, and any inexperienced user could obtain instructions as to what has to be done for certain conditions of the model environment.
During the GSM SIM 300, we have received a message on our mobile phone. As we can see here, the temperature and humidity value has been sent from the GSM SIM 300 to our mobile phone.
future scope of our project. Smart farming will soon be prevalent at every corner of the world due to ever-increasing soil erosion, shortage of clean water, and land requirement, crop damages due to animal attacks and pest infestations. A project could be used on a large number of such small installations with low power and water requirement, and also lesser instances of pest-related damages. This is a precursor to agricultural practice indoors, even without the use of sunlight, which could be replaced by low-cost LED growth lights. The nutrient solutions, when added in appropriate amounts, increase the growth of plants by about 50% as compared to the conventional system of agriculture. Addition of a pH sensor module along with the MSP 430 G2553 is possible using a SPI interfacing protocol. The pH values could be used as a reference while circulating the nutrient solution in the setup. The beauty of this technique is that it could also be used for cultivation of any kind of crop, perennial, annual or seasonal, and also in the art of bonsai along with other ornamental plant systems. We thank Texas Instruments for providing this valuable opportunity which has resulted in the increasing of our practical exposure in electronics and creating a new zeal for creation of systems which are useful to the society. We also thank Sambram Institute of Technology and our faculty mentor for supporting us during the course of our project and providing wonderful insight into the creation of the system.